Well, welcome back everyone to this round and round with the power transformer thing. If you watched the last video, you knew that, when I first dug into this thing, you knew that it burned out on us. When we were powering it up, we got it up to a little over 500 volts. And then, the wire burned again. It was probably very weak down in there underneath that paper and everything from where, it initially got burned. So what I did is I kept digging around and digging around. Let me get this pencil in here so I know what's going. I kept digging around and digging around with a pair of tweezers. I have very fine point tweezers till I was finally able to pull up a little strand of wire from where it burned off. And I've made a little link. Dropped the loop over the top of that wire and made a hook on the other end, hooked to the original wire where we soldered. So now I'm going to go ahead and we just basically bridged it. So what I'm going to do is I'm going to put a little flux here, a little flux there. Then I'm going to solder these two, and we'll go ahead and do a resistance check. I wanted to solder it right here. That would have been ideal. This wire coming across here. I pulled off a covering of paper there. Unfortunately, that turned out to be the center tap wire. And it was a direct, from here to center tap, it was a direct short. That's the green and white. Right there's the green and white wire, which is the center tap, and that's the wire coming down and coming out to where it solders down there. So wrong wire. So let's go ahead and get this thing soldered up, and we'll see what she looks like. Let me give you a little better close-up of what's going on here. Okay. The bridge is in. It is soldered up beautifully. Now what I have to do is check to see, I should have about 98 ohms of resistance between this, this enamel coated wire to the center tap. Now I've already connected up the wire to the center tap, which is right there, the negative of the meter. Let's go ahead and take the positive and watch our meter here and see what we get. Supposed to get 98. This time we got 99.5. I'm even happier. Not bad. Now let's try across the entire coil. Alright, I've got the meter lead hooked to the bottom of the coil where it connects to the 80 plate, the rectifier plate. Now this is the wire that will go to the other plate. I should get about 240. $239, 240. Perfect. Exactly right. Well, guess what? It's time to put the power to this thing again. Watch her smoke a second time. I'll tell you what. Before I do a voltage check, one of our good subscribers, Ron C., he said, John, maybe you had an arc between that curved wire you see there, right here, and the repair area. Maybe you had an arc and that's what caused the wire to fry a second time. I said, well, I didn't think so. And I told him that. But I was watching the multimeters, not the power transformers, trying to get the voltages right. So maybe it did happen. Well, I don't know. Well, we're going to do what we can to prevent that from happening. And, it's plenty of space there between those two. But I don't want to take the chance. You get up around 500-600 volts, yeah, there could be an arc. And that's a very tiny wire down in there. And one of our other subscribers said, you don't need that thick a wire to put on there. Well, I do, so I can see it, okay? Yeah, I understand that the current there is low, but what we're going to do is we're going to go ahead, we're going to just cut that baby. Just like that. And then we're going to bend this thing up, like so. I can get this thing in there where you can see what I'm doing. I cut that little arced piece of wire. I'm going to bend these things up out of the way. Completely away. Let me zoom in here. Completely away from where I made the repair. Now the interesting thing about this, see all this blackness down in here? My mentor Brendan, he said, another problem you're probably experiencing here is all this carbon. When these things fry, it burns the paper, it burns everything, and you get what's called carbon trails. And when you start applying voltage, it just goes from one side over the top to the other, and it goes all over around here wherever that carbon's at. So I don't know, maybe I better put some kind of a clear coating down in there or something, at least try to cover up this black crap before I bring the voltage up. And he said if I can just get this thing up safely to 500 volts, maybe we can get the radio to play. But anyway, right now let me go ahead and build a little loop-de-loop between these two that's away from here and try to get it all insulated and good to go. Let me work on that. Well, there you go. This is the way I decided to fix it. I just made a little loop of wire. I used regular old 22 gauge hookup wire, and it is totally clear now of this repaired area that we had. All I'm going to do now is move this heat shrink down on both sides and go ahead and shrink it up. Well, that's it. It's all done. The heat shrink has been shrunk, and everything is completely away from our previous repair and our second repair. Nothing will arc there. That doesn't mean it won't arc over here or arc back here someplace. You know, you never know. I've given some thought about using liquid tape on this. I don't think I want to do that. I might use liquid tape like to hold this down a little further and keep it in place. Maybe out here somewhere, I don't know. But it's just not a wise idea, I think, to put liquid tape across there, because this thing, you know, it could open again. And I might have to dig a little deeper in the well one more time. I mean, I'll dig as many times as I have to try to salvage this transformer. And because, you know, replacing him, if I can find one, can be very, very expensive. And since this was a free radio, I mean, you know, let's just keep the cost down to a minimum. That ought to make Mr. Mac real happy. And he's always, you know, telling me about my money. I've decided that prior to doing the next voltage check, I would go ahead and spray this with some clear enamel. Maybe that'll cover up some of the carbon trails, you know, keep them, you know, sort of semi-insulate them. You know, anything is going to help. And since I'm not going to unsolder any of these solder joints, I figured, what the heck, you know. We'll just go ahead and give it a spray down in there. Hopefully that'll do something. If not, well, I'll be working on the yard today. So while I'm working, I'll just go ahead and let it dry. Just kind of give it a shot down in there. It's the only thing I can do, really. Alright, that ought to do it. Here we go with test number 2. Okay, on the right, the voltage coming out of the wall and going into the primary of the transformer. On the left is the secondary voltage coming out. Now, for those of you who are just tuned in, what we're doing is I have the wall voltage, which is coming from my Variac, hooked to both sides of the primary, and we're testing the voltage. Let me zoom in a little bit here. We're testing the voltage on these two wires right here. This one, which I hopefully have repaired, and we're going to go ahead and test across here. So I have a meter between these 2 points, and I have a meter between these 2 points. So let's see what we get. Alright, let's start cranking up the old Variac. Well, let me see. I guess it would help if I turned down my power strip. Yeah, there we go. Now we got some light here. Alright, here we go. I'm going to turn up the old power Variac. On the right hand side is what's coming out of the wall, remember, from the Variac. On the left is what's coming out of the secondary. Well, that's not too bad so far. I've got the this is my secondary windings right here. Here we go. 61 volts at 12 volts. Man, I hope this thing reaches at least 500. Alright, let's go on up to heck with it. Let's go on up to 50 volts. I'm not going to worry about it anymore, you know. I mean, it's either going to work or it's not going to work, you know. Doesn't matter if it fries quick or fries slow, right? Alright. We are up to 500. We're up to 50 volts. We're getting 255. That's not bad. She's still holding. I don't see any smoke. Let's see, no smoke yet. All right. Let's keep it going. She's holding. I don't hear anything sizzling. Not yet. Last time I heard a slight sizzle before the wire burned in half. Alright, let's go up a little bit more. Let's go up to 75 volts. Get it over with. Make the pain quick. Alright. 380 at 75. Well, this is what happened last time until she fried at a little over 500 volts on the left over here on this one. Alright. Alright, let's go on up to 90 volts. Now, Brendan, my mentor, said if we can crank 500 volts out of this thing, we can probably get that radio to work. That should be enough to operate the plates on the rectifier, the 80 tube. Well, we're at 457 at 91 volts. No smoke yet, no sizzle, no nothing. Well, last time I said, gee, I think we have it fixed. Well, I'm not going to say that this time. Alright, let's go on up to, let's see what we get at 100 volts. That's where we began to have our problems last time. I don't see any smoke. If she smokes, it's over. You know, it's not like a little bit of smoke. I mean, it's either smoke or it's not. And if it smokes, it's open. 504. So far, so good. I don't know, that's really cutting it close. Let's go up a little bit more. I know my mentor's going, no, John, don't. Well, that's okay. That's all right. We can do this. We can do this. All right, 110 volts. 551. Not bad. Not bad. I'm not complaining, anyone. So far, so good. So far, so good. I can't believe it. I'd like to get it up to 117 because that's the voltage that'll be coming out of the wall after I put. That'll be the voltage coming into the primary of the transformer after I put my power transformer or my power resistors in. Get your mind straight here, John. Can I get up to 117? Yes, we can. There we go. I know this radio will work at 117 volts. Every radio I've ever had has worked at 117 volts. Darn. Did this thing actually get fixed? You know, it's pretty close to 600 volts, which is really very good. Well, I'll tell you, I'm going to go ahead and shut this down. And I'm going to have a discussion with Brendan about it. See what he has to say. You know, I think what we'll do is by the way, yeah, one more thing I wanted to tell you while it's sitting there cooking away. Someone asked, I said earlier what I would do is tell you what caused this thing to burn out. I thought it was excess E-cap, capacity. What happened was this radio was supposed to have a total E-cap of about, let me see, 6, maybe 8, maybe, I think it would be about, it's hard to read the descriptions on this, but I think it's like total, capacity in the electrolytics was 3 electrolytics, total capacity was about 16, 18 microfarads. But what someone has done in the past, they changed all the low value E-caps out and put 8 microfarads in place of each one, and then they added an additional 4th 8 microfarad E-cap. So that was 32 microfarads altogether, and I thought maybe it was just too much draw on the poor little transformer. But Brendan said no. He said it would have wiped out the excessive electrolytic capacitors, and adding a 4th one would have probably wiped out just the rectifier. And he said what actually probably caused this thing to go was a small bit of moisture got in there, shorted across, and then it just took out all the rest, and that was it. He said he's seen it happen 1,000 times. So I'm just going to go with what he said. Anyway, I think we're doing pretty good. What do y'all think? I don't know. Like I said, I'm going to let Brendan take a look at this. All right. Until next time, this is John. Well, I guess I forgot to show you what the upper half reads. You know, I showed you the entire secondary, but I needed to show you what it's reading from the center tap here to here was where it was broken, okay? And it's reading 233, and I think that's going to be enough. I think that'll be plenty to operate that plate in that 80 tube.